Welcome to today's lesson. In this lesson, we'll be looking at expressing numbers as a product of its prime factors. Example 1. Express 32 as a product of its prime factors. To do this, we will be looking at two different approaches, method 1 and method 2. Now in method 1, we'll be adopting the long division approach, 32. Now the smallest number that can divide 32 is 2. 2 in 3 is 1, remember 1. 2 in 12 is 6. 2 can go again. 2 in 16 is 8. 2 can go again. 2 in 8 is 4. 2 can go again. 2 in 4 is 2. 2 can go again. 2 in 2 is 1. Therefore, the number 32 could be written as 2 times 2 times 2 times 2 times 2. That is 2 times 2 times 2 times 2 times 2. The method 2 is called the tree and branch method. In this method, we will have to decompose the number 32. So we start by putting down the number 32. Now, the first prime number that can go into 32 is 2. Now, when we decompose 32 with 2, we're going to get 16. At this point here, we have 2, a prime number, and we have 16, a composite number. Now, we still have to decompose our 16. 2 will go again to decompose 16, and we'll get 8. At this juncture again, we have 2, a prime number, and 8, a composite number. So we'll have to decompose our 8 again. 2 will go into 8 again to give us 4. Now we have 2, a prime number, and 4, a composite number. The composite are 4, we get 2 here and 2. Finally, we've gotten a prime number as the last number, which we cannot decompose anymore. So all the prime numbers we got were 2, 2, 2, 2, and 2. Therefore, our 32 is the same thing as 2 times 2 times 2 times 2 times 2. Example 2. Express 150 as a product of its prime factors. In doing this, we will as well consider our two methods. Method 1, the long division approach, and method 2, the tree and branch method. We put down our number 150 here. Now the smallest number that can go into 150 is 2. 2 in 15 will give us 7, remainder 1, and 2 in 10 will give us 5. Now 3 can go. 3 in 7 will give us 2, remainder 1. 3 in 15 will give us 5. The next number that can go is 5. 5 in 25 will give us 5. And the last number that can go is 5. 5 in 5 will give us 1. Therefore, 150 could be written as 2 times 3 times 5 times 5. Method 2. In our method 2 here, remember we'll be looking at the tree and branch method, where we'll be decomposing the number 150. So we'll put down our number 150 up here. Now the smallest number that can go into 150 is 2, and when we decompose 150, we are going to get 75. Here we have a 2, which is a prime number, and 75, which is still a composite number. Now we're going to decompose our 75. 3 will go in, and we'll get 25. Here we have a prime number 3 and a composite number 25. So we'll decompose our 25 again. 5 will go into 25, and that will give us 5. Now we have ended up with our decomposition, because at this point we have 5, which is a prime number which we can no longer decompose any further. So we are done here. Finally, all the prime numbers we got out of this decomposition is 2, 3, 5, and 5. So our 150 could be written as 2 times 3 times 5 times 5. Index notation. To write a number in index form means to express the number in terms of its powers. Example, if we have the number 2 times 2 times 2 times 2. Now here we have how many 2's? 1, 2, 3, 4. So this could be written as 2 raised to the power of 4. Second example, 2 times 2 times 3 times 3 times 3. Here we have 2, that's 2 2's, and then we have 3, 3, 3. So we can actually write this as 2 to the power of 2 times 3 to the power of 3. Let's take a look at another example. Let's say we have 2 times 3 times 3 times 5 times 5. Now, here we have only 1 2, we have 3 twice, and we have 5 twice. So we can write this as 2 times 3 to the power of 2 times 5 to the power of 2. Now notice this. Here I wrote only 2. I didn't put the power 1 because 2 appeared once. Therefore, anytime you have any number without power, it's the same thing as the number raised to power 1. So you don't necessarily need to put your 1. Example number 5. Express 1000 as a product of its prime factors in index form. Now notice we asked it to be in index form. So when we are done with the expression, we'll have to write it in index form. We'll still consider our two methods. Method 1, the long division approach, and method 2, the tree and branch approach. So in our method 1, we put our 1000 here. The smallest number that can go into 1000 is 2. 2 in 10 is 5, and 2 in 0 is 0. 2 in 0 is 0. Now 2 can go into 500, so 2 in 5 is 2, remainder 1. 2 in 10 is 5, and 2 in 0 is 0. Now 2 can go into 250, 2 in 2 is 1, 2 in 5 is 2, remainder 1, 2 in 10 is 5. 2 cannot go anymore, so the next number that can go is 5, and 5 in 12 is 2, remainder 2, 5 in 25 is 5. 5 can go again, 5 in 25 is 5, and 5 can go again, 5 in 5 is 1. So we can write our 1000 as 2 times 2 times 2 times 5 times 5 times 5. That's 2 times 2 times 2 times 5 times 5 times 5. Don't forget, the question says we should put our answer in index form. So putting this in index form, that will give us 2 to the power of 3 times 5 to the power of 3. Remember that 2 appeared here 3 times. 1, 2, 3. And 5 appeared 3 times. 1, 2, 3. That's why we have 2 to the power of 3 and 5 to the power of 3. Method 2. Our method 2 is our tree and branch method. So we'll be putting our number 1000 up here and decompose it. To decompose our 1000, 2 can go into 1002, and when we decompose our 1000 here, we'll get 500. 500 is still a composite number, so we'll decompose further, and 2 will go into 500 to give us 250. 250 is still a composite number, so we need to decompose further. 2 will go into 250 to give us 125. 125 is still a composite number, so we decompose further with 5, and 5 in 125 will give us 25. Now 25 is still a composite number, we decompose further with 5, and 5 into 25 will give us 5. Now we are done because our last number here, 5, is no longer a composite number, so we cannot decompose it any further. Therefore, our 1000 here could be written as 2 times 2 times 2 times 5 times 5 times 5. So we write it as 2 times 2 times 2 times 5 times 5 times 5. 2 appeared 3 times. 1, 2, 3. And 5 appeared 3 times. 1, 2, 3. So in index notation, we'll be writing it as 2 to the power of 3 times 5 to the power of 3. That's the final answer. We have come to the end of this lesson. You can now proceed to the challenges to test your understanding. If you're not watching from our website, remember to visit plw.ng. It is fun over there. Thank you for watching. See you in the next lesson.